This is part 2 of Taylor series, and this is going to show you two examples, two very basic examples of the type of problems they might ask you to do or perform. So find the fourth degree Maclaurin polynomial. So this is just another way to write this. If they wrote p sub 4 of x, that'd be another way to write it. Fourth degree polynomial for f of x equals cosine x. So a couple things about the wording here. Maclaurin implies that we are centered at 0. We'll be talking more about what the center really means, but basically the center is our starting point. The center is also the number we're going to be plugging in. So if you go back and look at our basic formula, that's where you see all the red things highlighted. That's the general formula for Taylor polynomials. We need to be plugging 0 into however many derivatives we're told to take. And the number of derivatives we need to take is equivalent to the degree. So for example, they say the fourth degree, so we need to start with cosine x and go to the fourth derivative. So the first derivative is negative sine x, second derivative is negative cosine x, third derivative is sine x, and fourth derivative is cosine x. So what we do next is plug 0 into each of these things. And again, we know that because it's Maclaurin. And Maclaurin is always centered at 0. If it's some other center, they'll have to tell you it's centered at such and such. So that's not something you have to figure out. That'll always be given. But this is implied here because it's a Maclaurin polynomial. So we go back and we plug 0 in for all of these. So cosine of 0 is 1. Negative sine of 0 is 0. Negative cosine of 0 is negative 1. Sine of 0 is 0. Cosine of 0 is 1. Okay, now let's just remind ourselves what the general formula looks like. It's f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus f fourth derivative of f of 0 over 4 factorial x to the fourth. So all we have to do is plug these numbers in for the f's. So 1 goes in for f of 0, 0 goes in for f prime, negative 1 goes in for f double prime, and so on. So I will get 1, because that's f of 0, plus 0 times x, because 0 is f prime of 0, plus negative 1 over 2 factorial x squared, plus 0 over 3 factorial x cubed, plus 1 over 4 factorial x to the fourth. I'm sure you're asking, well, do I have to write those zeros? No, you don't. You can just cross those out. So your final answer should actually look something like this. 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth. So just to be clear, what we're doing here, and this again is our final answer, is we are using a polynomial to approximate cosine of x. So this will give us similar answers if we plug in a value for x that cosine does. Now, the fact that we're centered at 0 means if we plug in a number close to 0, we should be pretty close. Whereas the farther away we get from 0, the worse this estimate's going to be. Okay, second example. Find the third degree polynomial for y equals sine of x centered at 0 and use it to approximate sine of pi over x. So there's two things we're being asked to do. First, do exactly what we did in the first example, and that's find a Taylor polynomial, again centered at 0, so this could be called a Maclaurin polynomial. And then the second thing is take that answer we get and approximate sine of pi over 6. So basically we will plug pi over 6 into our final answer. Okay, so the fact that we have a 3 right here tells us we do the third degree. That means we need to do 3 derivatives. So I'll start with sine of x. First derivative is cosine x. Second derivative is negative sine x. And third derivative is negative cosine x. So now, since we are centered at 0, we need to plug 0 into each of these. Sine of 0 is 0, cosine of 0 is 1, sine of 0 is 0, negative cosine of 0 is negative 1. So again, our general formula looks something like this. And you should have this memorized. You should know this pattern and be able to spit it out when you need to. So now we take each of these values we just found and we plug them in where it's appropriate. 0 goes in for f of 0, 1 goes in for f prime of 0, and so on. So we'll end up with 0 plus 1x plus 0 over 2 factorial x squared plus negative 1 over 3 factorial x cubed. Now the zeros just go away, so you end up with x minus 1 over 3 factorial x cubed. And this is the third degree polynomial. Alright, so that's the first part of what they asked for. This is an approximation for sine using a polynomial, and it's centered around 0. Again, the idea there is that the closer we are to 0, the more accurate this approximation is. We kind of have a spot we need to anchor ourselves, and that's what's being done here. So then the second part is to approximate sine of pi over 6. So I'm going to plug pi over 6 into that equation I just found. So I do pi over 6 minus 1 over 3 factorial. Now you could also just call that 1 over 6 because 3 factorial is 6 times pi over 6 cubed. And we get 0.499. So that's an approximation for sine of pi over 6 because that's what our Taylor polynomial is. It's a way to approximate the sine function. So let's just, for the sake of curiosity, see how accurate this is. Because, you know, like I said, I think in part 1, the more terms we have, the more accurate we are. So we need to see how accurate we are with just 2 terms. So let's try sine of pi over 6. Well, I'd say that's pretty accurate. So that's a pretty good approximation. And pi over 6 isn't super close to 0. I mean, as far as that goes, I mean, it's, let's see, what is pi over 6? About 1/2 maybe? Oop, forgot my divided by. Yeah, so it's 1/2. It's you know, it's not right at 0, but it's pretty close to it. So our approximation is pretty good. So if we were asked to plug in something or approximate something farther away from 0, our answer would be less accurate. But things close to 0, this works pretty well for.